This video cover Chapter 10, Section 3, Quotient of Powers Property. The standard that this video aligns with is 8.EE.1. The objective of this video is to use the properties of integer exponents to generate equivalent exponents. We're going to divide the power with the same base. To do this, we have to subtract the exponents. Here we have a to the nth power divided by a to the nth power. Because they have the same base a, we would rewrite their base as a, and we would subtract their powers of m and n. So we have a to the power of m minus n. We're going to start with an example. Here we're going to simplify the expression and write our answer as a power. Here we see that we have the same base of 2, so we rewrite our answer with the base of 2, and because they're divided, we take 6 and subtract 4. So 6 minus 4. We will always subtract the bottom from the top, so 6 minus 4. This is the same as 2 raised to the second power, because 6 minus 4 is equal to 2. So our final answer is 2 squared. Let's try another example. Here we have to simplify the expression and write our answer as a power. Here we see that we have the base of -7. So we rewrite our base of -7, and we take our top exponent of 9 and subtract 3 from it. So 9 minus 3. This is the same as -7 is raised up to the 6th power, because 9 minus 3 is equal to 6. Let's try something a little more complicated. Here we have h raised up to the 7th power divided by h raised up to the 6th power. Here we see again that we have the same base, which is h, so we would write h, and then we would take the top exponent of 7 and subtract the bottom exponent of 6 from it. This is the same as h to the 1st power, because 7 minus 6 is 1, or just h. Now let's go on to something that's even more complicated, and that's multi-step. Here we see we have both multiplication and division. Let's start with our multiplication. Here we see 3 to the 4th power and 3 to the 2nd power multiplied by each other. As you remember from our last video, when we have two powers with the same base multiplied by each other, we add their exponents together. So, because our base is 3, we would rewrite our base of 3 and would take our two powers of 4 and 2 and add them together because it's multiplied. And we would continue with our division of 3 cubed. This can be simplified as 3 to the 6th power, because 4 plus 2 is 6, divided by 3 cubed. Now, we can do our division. Here we see that we have 3 as our common base again, so we rewrite 3, and we take 6, our top power, and subtract it from our bottom power of 3. This is the same as 3 cubed, because 6 minus 3 is equal to 3. And this would be our final answer. Let's try another example. Here we see a raised to the 10th power divided by a raised to the 6th power multiplied by a raised to the 7th power divided by a raised to the 4th power. Let's start with just this portion right here. Here we see that we have the same base and that they are divided by each other. So this is the same as A, because our base is A, and 10 minus 6, because they are divided by each other, which means we subtract. This is multiplied by our second portion here, where we have the same base of A, so we will rewrite A, and they're divided by each other, so we have 7 and 4, so that means we'll subtract our top power of 7 and our top power minus our bottom power of 4. We can now rewrite this as A to the 4th power, because 10 minus 6 is 4, multiplied by A to the 3rd power, because 7 minus 4 is 3. Now, because they're multiplied, we can add them together because they have the same base as A. So we would rewrite our base A, and we'll take 4 plus 3, because since it's multiplied, we add our powers together. So this is the same as A to the 7th power. And this would be our final answer. For further assistance, look in your book on pages 424 to 425. Here they have more examples that are worked out step by step. Your homework problems for tonight are page 426. You are to complete problems 3, 5, 13, 14, 16, 17, 20, and 21. This is to be completed before class on September the 17th, which is Thursday. These problems will be turned in at the beginning of class on Thursday, September the 17th.